G'day guys. I had a bit of a brainwave, and that can be a dangerous thing. But I had some thoughts on the GPX 6000 and about the handshake chip that is located in the coil on these detectors. I've been thinking about this, and as far as I can tell, and in my humble opinion, the only reason that chip is in the coil is to lock out people that want to make coils for these detectors, but they can't because they haven't got the chip. And I know there's a couple of other manufacturers that do manufacture coils, but I would, in my humble opinion, be thinking that those manufacturers are paying a license fee or a product use fee, or buying the chips from Minelab, and thus Minelab's making a bit of a profit, and it's allowing the manufacturers to make coils. Now, in my thoughts, I've been thinking about this. There's nothing special about the coil, as in the winding of the coil. So why put a chip in it? Unless it's just a means, in my humble opinion, of just locking out other people making coils. I can't see any reason for it. All it is a digital handshake. That's all it does, as far as I know. And in my opinion, that's all it does. I'm going to be very careful with my wording, so just bear with me on, I know it sounds a bit stupid saying in my opinion all the time, but I have to do it. I've been instructed to do that, right? Because it is my opinion. I've had issues with this before. It's not going to happen again. Okay, this cable here is the data line that tells the detector to turn on when the coil is connected. But the dongle, I call them dongles, right? I think in the early 80s we had software that we had to use, and if you didn't plug the dongle in the parallel computer port on the back, the software wouldn't run. It's the same thing, right? Whereas people started making hacks for the dongle, so you didn't have to use it. You could just get a software emulator, and it would get around that dongle problem. It's old technology, and it's reminiscent to me of that. Or if you haven't got that, you can't use this. I don't like it. I don't like I say, in my opinion, it stops innovation and it stops experimentation. But there's a way around it, all right? You can use any old Minelab coil, Coiltech coil, or Nugget Finder coil, Detect coil, or whoever makes the coils, homebrew coil on one of these detectors. And all you're going to do, right? First of all, this connector. Whoopsie, let's go in here. So I'm going to move it over. I'll put it under the light, or do I move the light here? I'll move the light there. There we go. That's probably a little bit easier. But you look at all those connectors there. Well, that is for the mono and the DD, those big pins, and the small pins, the ones at the top. I think there's two at the top and one at the bottom for the dongle. But what you need to do if you want to do this connector, you would take this off and keep the wires on it, right? You'd have to get rid of all this glue, a bit of isopropyl alcohol, let it sit for a bit, just wedge it, spray some more or whatever, isopropyl alcohol on there, and eventually it'll let go. It's a tedious thing to do. It's just going to break the surface tension between this glue and the plastic. that's if you want to hold it. It doesn't actually need this plastic. You can get rid of all that, and you know, you can just get this ferrite core here, and you could super glue it to the top of the receiver module if you wanted to. It's just, it looks neat in manufacture. It's not needed. If you did break it, so what? It mounts by this nut anyway, so it's not really a big deal. You know, it's got some bit through here. It does wobble around a little bit, so it's better to keep it if you can, but if you don't, bad luck. What I'm suggesting, this is only a suggestion, and this is only for the brave, and there's risk. There's risk in doing this, right? Because you've got to know what you're doing. But maybe someone out there wants to do this. Okay, I'll explain. The chip is in the coil, okay? So what you have to do, and I'll say this a little bit loosely, is you have to sacrifice your coil. And what that means is, well, if you've got a coil and you don't like it, well, it's not much good to you, is it? If you've got a double D or a mono and you like using one over the other. But this could save you a fortune in the long run. I'll explain. Okay. The old Minelab coils, for SDs, GPs, the older model GPXs are all over the place, and they are greatly reduced in price. I've seen some small 8-inch monos. You pick them up for 50, 60, 70 bucks. Dollars, Australian terminology. Or you can get the bigger ones. I've seen them $100, $150. It just depends who's selling what, but there's a lot of secondhand coils out there. So why not use them? And a lot of detectors have had the older model detectors and have still got tons of coils. So how about this? You open up the coil, the Minelab one that come with this detector here, right? And make note of the wire connections to the coil and to the board, okay? Get a multimeter and go from the wires on the board, write it down. Don't get a mirror image problem like some people do, where, this one is that one or whatever. Don't do that, but make sure you get it right. Take the dongle out, or the little chipboard, okay, and put it inside the detector, okay? All you need to do is connect it to the data line here. There's your data line there. I think it has a hard ground, a shield ground, and which is basically return, and the active part of it, which the signal comes in. But you need to check that. But if you get the wires here matched to here and then onto the board in the coil, sweet, it will work. So you could get your dongle. You could get rid of this wire. You could put the dongle in here. Nothing stopping you. I just put a little bit of a standoff up here. Keep it at the same level as these capacitor tops, and put the dongle in. Just bang. Put a standard, connector, standard 5-pin coil connector on here. Maybe you need to put a washer here to get the size right, because it's a bigger hole. But that's not hard to do, because you're not going to be using this anyway. Get rid of it. And on the coil that you cut, if you cut in the middle of the coil where the board is, there is an X-ray picture on the internet. Someone's taken a fellow by the name of Chuck, and it's floating around the internet somewhere. But if you put in GPX6000 coil X-ray, you probably find it. But I saw it on the internet. They'll give you a location of where the board is, and you could carefully cut into your coil, extract the board, join the wires back up. Don't worry about the dongle wires anymore, you don't need them. Put the dongle board in the detector, okay? Change this. Just make sure you wire it correctly. There's enough information on the internet to be able to do this with the coil connections. Um, so, you know, you can do this to run. I know you can do it to run mono. It's not a problem. Very, very easy. Um, I haven't looked at, there's no x-rays of the double D type coil. I don't even know if it is a double D type coil for the 6000. I know it said it's a double D coil, but I don't know. I've never looked inside that coil. I've never had a coil in my hand, so I don't know. And what you could do, if it is conducive, there it's got 2 input channels on the receiver, you could probably wire it up per how the double Ds work. I know there's probably a mixed transmit receive on one of these black wires here. These are shielded cables that come in from the plug. You just have to nut it out. You know, I can't really tell a lot by looking at the coil connector. There is a few things I can tell because I can tell with the meter, like on this bit here, the big fat ones. I think there's 2 grounds, earths or returns here, but I don't think they're actually connected together here. I think it actually goes up to the coil and is connected to, maybe it's a separate return, but they're both grounds. I mean, same potential. And I think, I'm saying I think because I can't remember which way it was now, but that's the active of the coil and there's the return. And some of these smaller ones here tie up onto the 3 connections on the data cable here, and that's your handshake signal. So the chip, the dongle chip, as far as I can tell, let me have a look. I just thought of something, right? And I don't know this. This could be an issue, could not be. Because I can't see what is on that board, does that board have a very fine wire inside the coil and a small capacitor and diode that actually, or should I say series regulator and a diode, that actually generates 3.3 volts from when you fire the detector up and gets a power from the energizing of the coil as a floating system? I don't know that. That's what I'm saying. This is for the brave. This is not for the foolhardy. But if it needs 3.3 volts, I think they're all 3.3 volts for these handshake chips. Well, because if you cut it off here and stick it in the board, there's 3.3 volt supply rails that go to the chipset on the board. So you can just take it off and connect it in that configuration. You might have to use a little series inductor or something just to get the signal out of the DC line, or stop it getting going down the DC line, getting absorbed out or something. But I don't think it's that critical. I really don't. But really, to know what's going on, we need someone who is willing to pull their 6000 coil apart and have a look. It's even like just doing a surgical operation. If you cut through the plastic on the top of the coil, I'd say that from what I saw on the X-rays, the board is right next to the coil cable. Now, another point I'll say about the coil cable, and this is my opinion, right? This is my opinion. If this cable here is used to transmit voltage to the coil and also is used to bring back the receive signal from the coil, and how many wires are in that, how big or how large in diameter is the cable bringing the receive signal back? And I'll say this for a reason. One of the biggest enemies in these detectors, right, is capacitance. And when you have I'll explain about the cables, okay? I'll explain something about the cables. You ever look at a monocoil on the older detectors? It's thick. It's got a lot of spacing between the inner conductor and the outer shield. And the greater that spacing, the less cable capacitance. Okay. When you have a signal come back, a fast transient signal from a decaying target that's been energized, I'll try and keep this simple. But what happens is it'll transmit, it will then go into receive, and it wants to look at this decay. It's a decay curve, right? And what happens is that on a fast transient signal, if you've got a lot of cable capacitance, it has to overcome that capacitance, like fight against it, especially small target signals, and then it decays. So if you had a difference in cable capacitance, say you had a cable with a very, very small overall shield diameter, and the inner conductor was very, very close to the shield and might have 1 millimeter of insulation around it, that's going to be very high capacitance cable, right? And also that depends on the dielectric used between the inner conductor and the shield. If you use something like Teflon, which you wouldn't because it's piezoelectric, it'll generate voltages as you do this, right? Do not use Teflon in cables, people, because it's like striking a crystal. It's the same, gives the same effect. It'll generate small voltages and your detector will go woo, 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 right? So don't do that. The best thing to use for insulation, we go back into the polypropylenes. Even better is cotton, if you can keep it dry. That'll have a dielectric of very close to 1, the same as air. That's what you want to aim for. You don't want high dielectrics. High dielectrics increase the overall capacitance as well. And as you pass a signal down a cable, right, very, very fast transient signals, what happens? It wants to fight the capacitance. The capacitance wants to squash it out. You heard of power supplies with filter capacitors? They squash out the waveform, the residual waveform from it being switched to your AC mains or off a chopper transformer, whatever. It smooths out this business. If you didn't have this, um, it would, whatever this frequency of the sine wave is, would translate into the electronics. If you had an audio amplifier without filter capacitors, all you'd hear is the mains hum, right? And you need them. They get rid of the mains hum. Same on this sort of stuff. Anyway, what we got a very, very tiny signal. I should really do this on the whiteboard, but you can follow my fingers, right? But what happens? You've got a tiny signal. It goes transmit, energizes the target. The target wants to go, coil picks up the decay of the magnetic field, turns it into an electric voltage. And what that does, it tries to race into the detector and go through the demods. Now, what actually happens is that it has to go through, we can look at the cable as a long filter capacitor, right? And you got a very fast decaying transient, which wants to go like pump up and then die off. Okay, what happens? It limits the amount of time that it wants to come up. It goes into the capacitance. It doesn't make that sound effect. I just did that, but it wants to go up and then it wants to decay. So what you're going to have minimal amplitude, and because of the capacitance there, you may have theoretically a longer decay that even decays off into your next transmit or dead time, and it's not going to be utilized in signal recovery. So you must strive to have low cable capacitance. Now, what I do on this could be an absolute winner, in my humble opinion. Get rid of this cable. Get rid of it. Put the dongle inside the detector, however it goes in there, right? And run proper, big, thick mono cable into your standard 5-pin plug, 5-pin socket, stick it together. And in my humble opinion, you should have a performance increase. That's my opinion. On small gold, it may even give an edge on large gold. See, this is interesting. Like, in my opinion, right, trying to protect um, your coil manufacturer and so forth may have, in my opinion, robbed the detector of some of its performance. Okay. Now, if a brave soul out there wants to try this and give it a go, well, good luck to you, right? But if you do, and there's a couple of guys I know who could do this. It's not for the, you don't do this if you're just not into um, knowing about electronics. Don't try and do this if if you run a Jim's mowing business or something for a living. Do not touch the electronics in these detectors. That was a bit of a joke, by the way. A bit dry, but anyway. But I think there's something to be gained. There's something to be gained. And if you do and it is successful, you can use any damn coil from history that you see. You can go around buying all the coils up and offering $100 each for them. I saw the price of the coils for these things. Why are they so expensive? My God. You know, it's a bundle of wire and some plastic. You know, anyway, I've said my piece. They are damn expensive for what they are. Mono cable. I can buy mono cable out of China for about $2 a meter, and connectors I can buy those out of Taiwan. What they cost me? 90 cents. Plastic housing. I don't know. What's it worth? $20. A bit of foam fill, probably worth $2.50. Copper wire. I don't know. It's lit wire. I was selling it for $1 a meter. $20. Why is the coil so expensive? Please tell me. It's just the gold industry. Um, you know, if you got gold fever, you're going to get you're going to have to suffer the consequences of having gold fever. Be sensible with detecting, and don't just go and buy a new detector because it's new. A lot of cases, there's no benefit. Now, I remember a particular company was always saying, I'm not going to mention this company, but was always saying, oh, it goes 30% deeper. 30%, 30%. Each year was 30%, or between each iteration of the detector was a 30%. So we've got detectors that now from day one, um, are over 500% deeper. No, they're not. They're lucky to be able to get a couple of inches in some of these detectors. Um, just go and study the laws of physics on magnetics, magnetic coupling, and then have a look at some of the signal recovery techniques. You've got to go to hard digital techniques to work below noise floor and stuff like that. And, I don't know if these things do it. I don't know. I didn't program it. I don't know. No idea. But like I say, um, it's a good detector. These are a good detector for what it is. But in my opinion, it's noisy. It is because of the extra gain or whatever. It's noisy. I know if I say stuff like it's going to piss people off, but hey, I don't care. I'm just going to tell the truth. How I see it. It's my opinion, right? It's my opinion, and it's what I've seen, what I know. And if it pisses people off, bad luck. But if you look at that, it's like all these things here. You could probably see these in a. Well, they do. They those things live in the GPXs. We get an old scrappy board here. And I say, oh, what are those? What are those chips there? Oh, I wonder what they are. Hmm. Yeah, and then we've got two 8-channel Delta Sigma ADCs here. That is not in the GPXs as far as I know in any configuration. um, I don't know. We don't know what's inside some of those chips. I don't know what's going on in the chips. I really am not into delving into the Hitachi chipset, what's used, or Renesas, or what do they call themselves now, in those GPX. That's someone else's domain. Yeah, that's basically how your signal gets demodulated through here and goes and does whatever else it goes on in the detector. Like I say, I didn't design it. I don't really know that much about it. Just the overall. You can see the power supply areas. You can see signal recovery areas. You see transmit. You can see this. You can see that. And yeah, and like chips like this, what goes on in that? Who knows? The guy who designed it. And that's probably where it stops. Unless you get the programming data, which you never will. You just don't know what's in that. But then again, it wasn't the point of making this video. The point of making this video is seeing what can be done to get around the limited coil problem with these. Say if you wanted to go put a 25-inch mono on it, right? I don't know what, if you bought one that was chipped, what would it cost? And if you went and bought one second hand, you'd probably get it for a couple $100. That's what I'm saying. There's a big cost benefit in putting the dongle from inside the coil inside the detector and just feeding the data. It's going to go hello, and it's going to go hello back. It's going to say, I want to see this. Here, see this. Oh, I'll turn on now. I'm happy. And you just work it on any coil. That's my opinion. And I think that would work. I think it's quite feasible. I don't know. Maybe I should go over to the Geotech forum and put it up there, because there's a lot of technical guys on Geotech, and maybe one of them has one of these and would be brave enough to try it. And if you are brave enough, hey, if you are brave enough to give it a go, and you want a few pointers if you try it, like I say, it's high risk, but you can always contact me and ask me if you get stuck, and I could give some advice. You know, is it advice? I don't know. I shouldn't say that. I could give some opinion. There you go. I'll give some opinion. But there you go, guys. Is it worthwhile doing? Do you really want to hack into your GPX6000? I don't know. If it was out of warranty, I can't see the issue. The only thing is if you did something really dumb and shorted out the transmit, but it does have. I think I saw some current limiting or current sensing resistors, so maybe that would protect the output stage. And it's only some MOSFETs anyway, surface mount MOSFETs driving it, or one, I think. Is it two there? I don't know. It's a bit of glue on the bottom of the board. Can't see everything. But you could play around with this. Just make sure you don't damage this module here. That would be a total embarrassment. So don't go stick high voltage up the input of that. If you do experiments with this, you could actually get the input pin on this, and just for testing, right? Put something like a 100 ohm resistor in series with the input to this module to the input cable. That if there was something, you did something catastrophic, and you put transmit voltage into the module or something, or whatever happened, the resistor will limit the current. Might even be better going to 1,000 ohms. You'll still be able to receive a signal, even with a 1,000 ohm resistor there, just that you're not going to have much signal, so you'd have to really use a decent sized target to get a thing. But that would protect the input of that. No matter what you did with a 1,000 ohm resistor there, you won't blow it up unless you're stuck in the PowerPoint. Uh, but no, in all honesty, I think there's something to be gained, especially in how many coils you can use on this without spending thousands and thousands of dollars. You can do it for hundreds. And if you're a coil builder, you can do it very, very cheaply. But anyway, that's enough of this video. That's all I've got to say on this GPX6000. I've got to do something else to this. I'm doing this for that the person who owns this one up there, and I intend shipping this back to him during the week anyway. I've one of the 7,000 has gone back to its owner. It's out being swung around today, as far as I know. So the phone hasn't rung. It must be good so far. Uh, no news is good news in this game. Apart from that, yeah, that's it. Anyway, leave it there. And if you want to know anything or you got any questions, just put them in the comments. I read them all. It pops up on the phone, so I'll just answer it when it pops up. And yeah, see how it goes. Catches.